Okay, so we're going to be going over section 1.2, which covers exponents and radicals. So here we can see our variable n is raised to the exponent n. Our a is the base, and this means that n is just multiplied together n times. So here's an example, and just a little side note. I just want to clarify that these two are different. And the reason for this is the parentheses. So here, our whole -3 is squared. And that's going to equal 9. Here, 3 is squared, which is 9. And then we add the negative. So you guys should be familiar with exponents from previous courses. But here's some important laws that maybe you need to brush up on. So for our a does not equal 0, our n is going to be in the positive integers. So a0 actually equals 1. Sorry for all these emails popping up. But our a negative n, when our exponent's negative, that means that it's going to be a fraction. So to get rid of the negative, we're going to kick it down to the denominator. Here's the product rule for exponents. So when we're multiplying two things that are the same base but different exponents, we add them. So keep in mind that these are all same base. And then this is the quotient rule. So when we have them as a quotient, we subtract the exponents. And then here, our am is to the nth power. So we're going to multiply the exponents. So a way that I remember to differentiate between like am, an, and am, n is here it's like the distributive property. You're multiplying them. And so that's how I differentiate the two. And then abn, the n gets like distributed. And then, let me make a note here. Different distribution. And then here, the n is still distributed to both the top and the bottom. Okay, so you guys could come up with some examples on your own or check out the ones in the textbook. Add some new pages here. Alright, so now we're going to do some examples where we simplify. Oh, I didn't capture simplify expressions with exponents. So let's do an example. So here, the first thing that we're going to do is we're going to distribute this exponent 3 to all the terms in the parentheses. So we have -3, 3, x fourth to the third, y fifth to the third. And then we're going to keep this here so we can deal with these other ones. So here, distribute the 3. That means that we're going to be multiplying. Same thing here, distribute the 3, multiply. Okay, now, -3 to the third, that's this. -3, -3, -3. So these, -3 times -3 is 9, and 9 times -3 is -27. 4 times 3 is 12, and then 5 times 3 is 15. Good job, guys. Okay, let's do another example that's a little bit trickier. here we're going to have two expressions that are multiplied together. Don't be afraid to take these problems slow so we don't lose a negative or lose an exponent or mix up rules. So here we're going to combine like terms. So we have like -7 is multiplied by -2. And then x is multiplied by x to the 5th, y 4th, y 6th. So it doesn't matter the order of the terms, but I'm just grouping them together. We could even drop the parentheses in the beginning and it's just one big long multiplication statement. So we know this is 14, and then we add the exponents, right? Because there's no parentheses, we're not distributing any exponent. Same thing for the y. That's going to be equal to 14 x to the 6th, y to the 10th. Awesome. Okay, let's do another example. Feel free to pause the videos after I write the examples as well, and just try and do them on your own, and then check back to see if you got them right. Oh, we're adding in a negative exponent. Okay, so we're going to go ahead and group the like terms, and then it's division. We could break it up, the fraction up like this, because it's multiplication. Alright, so -35 divided by 5 is -7. And then we have x 2 minus 6. And then y 4 minus -8. Because we're doing the quotient rule, right? We're bringing this one up, the bottom exponent up, and then subtracting it. So this is -7 x to the -4. And then y, that's going to be like that, 12. I'll go ahead and erase this so you guys don't get confused if you're looking back, but y 12. And then to simplify it, we could go ahead and move the x to the bottom to become a positive exponent. All right, go ahead and do another example. Okay. Okay, so the first step that we could do here is distribute the -3 to the numerator and the denominator. And then we're going to distribute and focus just on the numerator right now. So this is going to be 4 -3, and then we have x squared -3, keeping the y. Okay, so let's look at the x squared. So we're distributing the -3 to the squared, which means that we're multiplying the exponents. Right, and then I'm going to go ahead and move the y to the top so it could become positive. And then I'm going to move the 4 and the x down so their exponents can also be positive. And then I'm just going to do the 4 cubed. And that's it for that. Okay, I'm going to go ahead and stop this video, and we'll continue section 1.2 with scientific notation and radicals in the next video. See you guys then.